Let us continue the numericals. One more numerical related to the relative loading of vapor pressure. It is given in the numerical that urea, how much urea is means amount of urea I have to find out. Urea needed must be dissolved in 50 gram of water so that the vapor pressure at room temperature is reduced by 25%. Vapor pressure is reduced by 25%. Also calculate the molarity. You have to find out the molarity. So how you will calculate this? Numerical how you will do? Let P1 naught is 1 atmosphere. It is reduced by 25% means P1 will be 0.75 atmospheric pressure. You have to find out the molecular weight of urea. If you calculate it, it comes to 60 gram. W1 is the weight of the solvent, is given as 50 gram. Okay. M1 is the what? Molar mass of solvent. It is how much? 18 gram. So P1 naught minus P1 upon P1 is equal to W2 into M1 upon M2 into W1. So if you subtract 1 minus 0.75, you will get here 0.25 upon 0.75 equal to W2 you have to find out. This is 18 gram upon 60 into 50. Okay. Calculate it. I think it comes to 44.3 gram. Now I will calculate the second part, that is the molarity. M will be equal to number of moles of urea upon what? Mass of solvent in 1 kg in kg. So 44.3 upon 60 gram into 50 into 1000. So calculate it, you will get the molarity. So more problems are given in the chapter. I'll tell you those. So go through the examples given in the chapter. Okay? Then let me continue. The next qualitative properties were elevation in boiling point. The temperature at which the vapor pressure becomes equal to the atmospheric pressure. You know it is known as what? Boiling point. The temperature at which the vapor pressure of a liquid becomes equal to the atmospheric pressure is known as boiling point. Okay. So temperature at which the vapor pressure equal to, it is equal to how much? 1.013 bar. And boiling point of water is how much? 100 degree Celsius. So if we add a non-volatile solute in it, the solvent, you know there will be decrease in vapor pressure. Means the solution will have to be heated to a higher temperature to attain the atmospheric pressure if you are adding the non-volatile solute, because there is decrease in vapor pressure. So boiling point will be more than the pure solvent of solution will be after adding the non-volatile solute will be more than the pure solvent. So if Tb is the boiling point of solution and Tb naught is the boiling point of pure solvent, Tb is the boiling point of solution means after adding the non-volatile solute, and this is Tb naught is the boiling point of pure solvent, then there will be increasing boiling point. Means we have to increase the temperature, so that is we can say this as the elevation of boiling point. Let it be del Tb. It will be equal to, which one is more higher? Tb is more than Tb naught, so Tb minus Tb naught. In this way you get the elevation of the boiling point. I hope you have understood. So graphically also you can represent this, whatever I have explained you. Let us represent in the graphical form by plotting the vapor pressure with temperature. Graph between vapor pressure and temperature. Suppose the graph here, this is for atmospheric pressure, that is 1 atm, you can say 1 atmospheric pressure. So we will be having two curves, one for the pure solvent and another for the solution. So for the solution, the curve which will be below will be for the solution and this will be for the pure solvent. So let it be AB and this may be CD. Now the point of interaction of this curve at the 1 atmosphere pressure curve, this will be the boiling point of this will be for the solvent, this for be the solution. So if you join this, extend this, then the gap between these two will give what? Del B, that is equal to Tb minus Tb naught. This is Tb and this is Tb naught. Tb and this is Tb naught, pure solvent in Kelvin. Okay. In this way you can represent the by graph the elevation of boiling point. Suppose you have taken water plus sucrose, you will get the aqueous solution of sucrose. So vapor pressure of sucrose solution will be less than 1.013 at 373 Kelvin. So the solution will not boil at 373 Kelvin. In order to boil, temperature of the solution must be increased or heated to become equal to 1.013 atmospheric pressure, and that is nothing but the elevation in the boiling point. Whatever the temperature that will be increased and you get the boiling point, it will be the elevation in the boiling point. So in this we have seen boiling point of solution is higher than that of the pure solvent. So del Tb equal to Tb minus Tb naught. Experimentally it has been found that the elevation of the boiling point del Tb is directly proportional to its molarity. Okay, or del Tb equal to Kb, a constant of proportionality constant, into m, that is molarity. M here is molarity of Solution, that is the number of moles of solute dissolved in 1 kg of solvent. Kb is the constant of proportionality and it is known as boiling point, elevation constant, or it is also known as molar elevation constant, or it is also known as abelioscopic constant. So what is the unit of Kb? It will be Kelvin kilogram per mole. So elevation in boiling point is directly proportional to molarity. So how to determine the molar mass of the solute from the elevation of boiling point? Let W2 gram is the mass of non-volatile solute. W1 mass of solvent. M2 molar mass of solute. So you know that M is equal to moles of solute in 2000 upon weight of solvent in grams. Moles of solute is equal to W2 upon M2 in 2000 divided by weight of solvent is W1. So M is this. So we have seen that del TB is equal to Kb into M. So put this M here, or you can write like this, del TB equal to Kb into M. M is this. So this is the formula for determining the molar mass of the solute. Again important, numericals are very important here. So let me take some numericals. A solution is prepared by 1.25 gram of methyl salicylate in 99.0 gram. Okay. Boiling point given is 80.31. Has a boiling point of 80.31 degrees Celsius. Calculate the molar mass M2. So let me read again the numerical. A solution prepared by dissolving 1.2 gram of methyl salicylate in 99 gram of benzene and has a boiling point of 80.31 degrees Celsius. Calculate the molar mass. Okay. Kb given is for benzene is 2.53 Celsius kilogram per mole. So del TB equal to Kb 2.53 into 1000 W2 is what? .25 divided by, or let me write, it will be easier if you write M2 here to calculate. No? So M2 equal to Kb into, in this way you can write, it will be easier for you. Kb is 2.53 1000. W2 is 1.25 gram. Del TB is given as 80 point. अच्छा, one more thing is given. Sorry. AB for benzene is given as, ये तो हो गया था, boiling point of benzene is given as 80.10, है ना. I will find out TB. Del TB is equal to 80.31 minus 80.10. That will be equal to how much? 0.21. So del TB is 2.21 and W1 is 99. So let me write here. KB is equal to 2.53 into 1000 into 1.25 divided by 0.21 into 99. If you calculate, you will get the molar mass. That is, it comes to be 152. So solve the numericals that is given in the test.